So we need to compute this variance in the spin x, and for what state we need to do, we need to take the sz, and using that we need to check if this result holds, where a is spin x operator, b is spin y operator. Okay, so sz plus state, we denote it just like this. We know that this is what the spin z plus eigenstate is. Now we are interested in finding average value of spin x for this state. So plus 6 plus 8. We know that what the spin x does is it takes plus to minus and minus to plus. So what it will do is some number, and this plus state will become minus, and this will be 0. Okay, next is sx square. So we know that spin operators are basically Pauli matrices. So when you square it, it does nothing. So we get the same number squared. This will remain as it is. So the delta sx square is just square by 4. Similarly, for spin y, we know that it will be 0 for y square. Okay, we can, so spin y also does the same thing, except it gives you a phase, but since it is squared, it will be nothing but again square by 4. Okay, so when you do this, you have h power 4 by 16, and the next part is you take the commutator of sx and sy, you have I h bar z, and for the state, it is eigenstate of this, we get h bar over 2 plus h bar over 2. Okay, so what do we have? By 4. Okay, so it is actually equal. Because for both we got 4 by 16, and this also we got h4 by 16. Okay, so we verified the first part. Now we can check again, but this time the states are different. Okay, so for case B is Sx, B is Sy, but the states are Sx plus, which is nothing but superposition of this. So when we calculate the variance, so there shouldn't be any variance. One can guess that because since we are calculating for spin x only, so average value of spin x for spin x eigenstates, what it should be, this is x plus x. So we know that it will do nothing but swap the states inside, which will be minus and plus. So when, yeah, this will be 1 by square root of 2 times bar 2 and plus plus minus minus bar 2 is expected. And similarly, we take sx square. Sx square will be equivalent to doing nothing actually. So since it's an identity operation, so that will also give us bar square upon 4 times, yeah, okay. So when you calculate delta Sx square, it will be square, which we expect there is no variance because the states are spin x eigenstates. Okay, fine. Next part is we need to calculate the Sy. So spin y is also same as spin x. It swaps minus to plus and plus to minus state, but with a phase. There will be an I and minus I. So okay, of course there is an bar upon 2. So yeah, we will have this plus will become minus, this minus, there will be minus n by root 2 positive plus n by root 2 negative. Yeah, so this is anti-symmetric. There is same negative I part and same negative plus part. And there will be 1 by 2 I minus n by 2. Yes, same. So spin y is 0. Okay, fine. Next part is spin y square. We know this will be same as doing the identity. So yeah, write it here. Square by 4. Okay. So delta sy square is square by 4. Okay, fine. And the commutator of x plus y by h bar is set. So the RHS part is by 4 h bar square square, and we know what is spin z. So we can calculate the sz. That is plus z plus. So this will give us h bar upon 2 and by square root of 2 plus, and there will be positive, negative. This will be 0. So this turns out to be 0. We know that for delta sx square was also 0. Delta sy square, we get some finite value, square by 4. So the third part is also satisfied. Yeah.